Hello, Year 6. Happy Wednesday, already midway through the week. How quickly they are going. Well done to those of you that have completed the last My Maths. I can see some really good scores coming through, which is excellent. Your next two pieces of My Maths are on and ready to go. It's on timetables, so reading timetables, still linking with time, and conversion graphs linking to converting units, which obviously was this week. Now, timetables you will have done in year 4. We did a bit last year, so that's sort of revisiting for you. Conversion graphs is something new. We haven't looked at those specifically, but I think you will find it pretty easy. Now, timetables then, just really quickly whizzing over this. The timetable below gives the times of trains from Far Forest to Uppercut. Now, this here is the station, Far Forest. This is Longmoor, High Hill and Uppercut. Now this would be called, this train obviously going along here, this is train 1, this is train 1, this is train 2, this is train 3, and this is train 4. Okay, so this would be called the 1741 train from Far Forest. This would be called the 1955 train from Far Forest. This would be called the 2110 train from Far Forest, and this would be called the 2326 train from Far Forest. Okay, and obviously this here would be called the 1820 train from High Hill, and all of them arriving at Uppercut. And we know this is all in the evening. They've used 24-hour time. And we could convert those to 12-hour if we wished, but remember that we do need to put on AM and PM if we are converting to 12-hour. Okay, so questions are similar to the ones here. I'll just talk you through a couple of them, but I think you'll be absolutely fine. You will need to draw yourself a number line again. How long does it take to get from Far Forest to High Hill? So how long does it take to get from Far Forest to High Hill? On the 1741 train, Far Forest to High Hill on the 1741 train. So that's this train here. Well, it leaves Far Forest, it departs at 1741 and it arrives at High Hill at 1820. Well, it takes 19 minutes for it to reach 1800 hours, and then it's another 20 minutes, so that would be a total of 39 minutes, just over 0.5 hours. Okay, the second question, the 1955 train, so I know that that's referring to this part, from Far Forest arrives at Uppercut 37 minutes late. When does it arrive? Right, hold on a second. If it arrives late, that means it is after the time planned, so I'm going to add on 37 minutes. If it was early, it would be before the planned time, so I would take away that time. But this one here is late, and it's 37 minutes late. So I would do myself a number line. I know that it is late. That's typical for trains. So it's 1955, and I need to add on 37 minutes. Well, I'm going to add on 5 straight away to get me to 2000 hours. I'm then going to add on another 30 minutes. That gets me to 2030. I've added 35 already, and I need to add 37, so we're doing another 2, so that's 2032. So I'll type in there 2032. So that's the time it arrives because it's late. Straightforward, use your timelines, you can't really go wrong. Remember that you cannot use a formal method. It does not work for time. Now, then conversion graphs, which is something new. A conversion graph is a graph that can be used to, funnily enough, convert from one unit to another. When we're talking about units, you know that we're talking about centimetres, metres, kilometres, ounces, pounds, whatever. Usually we'll be referring to metric units, which are those modern units that we would tend to be using today. Just really quickly, we can remember that 5 miles is 8 kilometres. Okay, so you can see here we've got miles on the x-axis, and we've got kilometres on the y to the sky on the y-axis. Okay, so I could convert with a line going like that. Okay, Now, this is the question you've got then. So here is your conversion line, which is that one. Okay, that's key. You're going to need that. And we need the question says 30 miles, right? Well, I'm using miles, so I would use my ruler, go up from 30 till I hit the line, and I need to be really precise, which is not there. It's quite hard to do. 30, okay, and then I need to draw along again. So I go along from there until I get to my point. Well, I would say it's about probably 40, that would be halfway 30, so it's a little bit less than half. I would say it's about 48 kilometers, okay, roughly. So that's your conversion graph. So draw your rulers to use your line. Now, same thing again. Hopefully I can use my here. So we've got two temperatures. We've got Fahrenheit, which we measure temperature in, and degrees Celsius. We tend to use degrees Celsius now, but degrees Fahrenheit is used more in science. So we need to convert 180 degrees Fahrenheit into degrees Celsius. Now, degrees Celsius is on the x-axis, Fahrenheit's on the y-axis. I need to find 180, which would be just above the 175, so roughly about here. And I go all the way along to my standard line, which is there. Now drop it down because I want to put it into degrees Celsius. So I would say that that is about 82 degrees Celsius. Now, you know that this is a conversion graph that can't give you an exact answer. It's not done by the computer, so they will give you a leeway, okay, a bit either side of the correct answer, 81, 82, 83, but they wouldn't accept 80 because it's definitely not on that line, and they wouldn't accept 90 because it's definitely not, and they probably wouldn't accept 85 because it's definitely not halfway between. Okay, so that's really quite straightforward. Now, the second question is more complicated, and it involves using two graphs. Use these two conversion graphs to convert Canadian dollars to euros. Well, here's my Canadian dollars, which is here. This is pounds. On this graph, I've got pounds and then I've got euros. So I need to get from Canadian dollars to pounds, and then I need to get from my pounds from here, which I can transfer to here, in order then to get me to euros. So you're going to have to do it in a few steps as opposed to the last ones, which have been done just in the one step, okay, or one graph, I should say. So first things first, it says how many euros are there in 168 Canadian dollars? Right, well, here's 150. These are my Canadian dollars here because this is pounds, so I'm using my x-axis. 150, 160, 170, 180, 190, 200. Right, we're going in tens. 168, then close to 170. So I'm going to go up this line here. Pretty much hits the line just then, really close to the top. So I would say that's probably about 98 pounds. So 98 pounds, I would say, is roughly 168 Canadian dollars. Now that I've converted Canadian dollars into pounds, I can now convert my pounds from this graph here into my required unit or currency for the question, which is euros. So I know that I need to convert 98 pounds into euros. So same thing again. 98 pounds is really close to the 100, up about there, maybe slightly to the left, but it's an estimate, so it doesn't have to be exact. Okay, and then I'm going to go over here. Now, so I then need to read off whatever this value here is. Now, 50, 60, 70, 80, 90, 100. Again, it's going in tens, so 110, 120, 130, 140. So 110, I would say it is about roughly 112 euros. So my answer finally would be 112. So you have to convert into something over here and then use that value to get over here and do your final conversion. Okay, and that's all you have to do. Question one of the conversion graphs, My Maths, is I think 20 questions that you just quickly do. Question two is just one question like this. Okay, good luck. I look forward to seeing your scores. Thank you to those of you that are sending the White Rose Maths to me. I know Robbie sent some through. Next video from me will be on Monday, so I hope you have although it's only Wednesday, a lovely weekend when it comes around. Hopefully some nice weather. Remember, I hope you stay safe as well, and I look forward to speaking to you on Monday. Thank you.